Guten Morgen, as my German friends would say. Good morning for those that speak English. Today we're going to be doing a tutorial on the Pimoroni PICO Display. It's a very nice little PICO display. The package is exactly the same size as the PICO itself. As you can see, physically they're the same size. Normally, the female headers on the back of the PICO display connect right to the PICO, and they're back to back. Now, this display has some really nice features and buttons, as well as an RGB LED and some nice resolution and plenty of colors. So all around, it's a very nice display. It's properly sized for the PICO. And in truth, I've been using one since about the beginning of this whole Raspberry Pi PICO filming series. And I'll show you why. This crazy contraption here is very important for the production of this video. Right now, there are 3 things being recorded. Here on this camera, you'll see that I've got the clock here. Then I take the little sync clock and I hold it in front of that camera. And that way that one knows what time it is in relationship to the rest. And then here on the desktop for the programming computer that I use all the time, I've got the master clock. And this one is just a regular timer within Windows, and the other one I sync to that one and then sync all the recording devices. But this has been working for me very faithfully. It's been a neat little project. Moving on into what we're going to cover today, we are going to go through a full tutorial. I'm calling it Part 1. There are some features of this that I'm not getting to work just the way I want to. So I don't want to produce bad information. Perhaps it's something I'm misunderstanding or something to that effect. But I do plan to do a follow-up on this later down the road. But this is the PICO graphics tutorial for the Pimoroni displays. Now, in particular, we're using the PICO display, but there are several other displays that work with this camera or with this PICO as well, and they use the same library. Now, what we're going to cover in here is installing the correct UF2 file. You cannot use the UF2 file from Raspberry Pi. It will not function correctly. We'll go through initialization and configuration, code format and flow, drawing some basic graphics, displaying text on the display, using the RGB LED, using built-in buttons, the 4 that are on there. And then if we have time in this part number 1, I'll be showing you how to connect the display to the PICO without using a backer board such as I'm using here on the workbench right now. This is just very, very convenient, and it works brilliantly well, especially for filming and presentation. Before we go into the coding and everything, let's just take a look at a couple of sample screens that I've created for other projects. Here on the PICO display, we're seeing what would be a thermometer, an analog style, and we've got Fahrenheit and Celsius, so we're using text display information and then line drawing as well as rectangle drawing primitives. Another example program is this particular one, which is a bar graph display. And this is part of a sound level meter project that's coming up in a future video as well. But in this case, very simple block diagrams, or rectangles being plotted in various colors, as well as showing you the actual digital value. Very simple to program and adds a nice visual feature for your projects. As mentioned earlier, it's very important that we get the correct UF2 file loaded. And for that, you're going to go to the Pimoroni website. On the Pimoroni website, you'll navigate to the product. It's called the PICO Display Pack, or something similar. But once you find the product, and I will have a link in the description below. You want to scroll down where it says Getting Started, Custom MicroPython UF2. You must go and fetch one of those files. So you'll follow that link. That'll take you to this page. Currently on version 1.1910, and I believe that's the one I've got loaded in right now. There will be several choices. If you're using this on a Pico W, you would have to select one of the ones labeled Pico W. In my case here, it's just a plain ordinary Pico, and so I would select this particular file. If I was working with the LiPo battery pack or the Badger product, we would select other ones. Make the correct selection for the display that you're using. So you would download that and install it just like you do with the one from Raspberry Pi. To use the display, we need to, of course, load some libraries and get things ready for it. And I call that initialization and configuration. So we'll load the library, create the display object, and then we're going to configure some of the display settings. So let's take a look at that in code. Here I'm loading in pretty much most of the library. From the Pimoroni library, we're loading in Button, Pico Graphics, I'm loading in Pico Graphics, and then importantly here, this next item, Display Pico Display. This is the class for this particular model of display. There are other choices. I'll show you more about that in a moment. And then this particular one, we're loading in this graphic or color profile that can be used with it. It's a very small memory usage one. It's using minimal colors, just 16 colors, which works for the vast majority of the projects you would ever do with a little display like this. Next up, we'll create the object, the display, and that is through Pico Graphics, one of the libraries, Pico Graphics, and we're going to set the display to the one we imported here. We're going to set the pen type equal to the library that we loaded here, or the class. And then finally, we're going to set the rotation of the display. The display can be shown in one of 4 orientations. More on that in a minute. Now, from the code, we saw that we needed a few libraries, and these would be the bare minimum. Obviously, the buttons aren't needed if you're not using them. These are the supported displays that this library handles. And as you can see, there's quite a few here. And of course, the library would need to know which one you're using in order how to lay out a memory framework for the buffer between when we write data to this buffer and how it is displayed on the display. So we use the Pico Display 240 by 135 SPI interface, and this is what it's called. That's the one that we would load for this particular display. And then we're going to create an object, as I've shown you in the program. Display equals Pico Graphics. We will select that class in the library, this pen type, that display model type, and then, of course, the rotation. Now, this one here needs a little more explanation. We could have just a pen 1-bit, and that would be mono, and it would be for a very limited type of display as they're showing here. You could use 3-bit, pen 3-bit, underscore 3-bit. That would be 8-color, and that's, again, used for an inky type frame. Not quite on these more fancy, colorful LCDs. And then the bare minimum one for this particular display is the pen underscore P4 for 16-color palette of your choice. You define the colors. And this is probably the one that gets used the vast majority of the time, unless you're doing some very fancy and elaborate graphics, in which case you can go up to 256 fixed colors from which to choose from, 64,000 or 16 million. Now, the drawback to these really fancy ones, each one uses more memory. The Pico has a limited amount of memory. You can run a 16 million color, but it's going to take up the bulk of the RAM that's available for you to do any other logic processing. So pen underscore P4 is probably the most commonly used. And then the rotation can be 0, 90, 180, or 270. If we go back to the bench, this is orientation 270, and this would be orientation 0. So you can specify whichever side you want up, and then, of course, if you rotate it, that will rotate the coordinate system too. Luckily, their library does a brilliant job of making that easy for us. We'll take a look at that in a moment as well. Here you can see the coordinate system for rotation 0. X-axis would be X plus, starting here in the upper left-hand corner, going to the right at 240 pixels, and then Y plus going down at 135 pixels. If we're using rotation 270 in the vertical format like I've been showing thus far, X would be then 135 pixels wide and Y plus would be 240 pixels tall. If some of you more advanced users out there can explain to me why on earth in a lot of graphics commands for computer graphics, they use Y plus going down instead of up. To me, this should be Y negative in a traditional Cartesian coordinate system. And in truth, I think it's been this way going all the way back to, as far as I can remember, and I think it goes back to, oh rats, I don't have it here anymore, but even that old Timex Sinclair 1000 that I've got. So if one of you guys can enlighten us on why they did that kind of backwards to Cartesian coordinates, share with us. We'd like to know. But that's your coordinate system that you'll work with for all your graphics and text positioning. Now we'll be taking a look at the code format and flow. So first we'll look at the code, and then we'll come back and look at some more details. Here in Thani again, we're going to take a look at the additions of codes, and that would be this block here. And this is, I'm going to say, somewhat boilerplate still. One of the commands is to allow us to set the backlight, select the font that we're going to use, define some colors, and then we're going to create a subroutine, or a function rather, to make life easier for us in our programs. Before we go into detail on this, let's now take a look at the description of this information. All right, we're going to create a pen, and that pen would be defined by a number, an 8-bit number between 0 and 255, for specifying the intensity of red, green, and blue in that order. Then we would set the pen. Now we're going to say, for example, red equals create pen 25500, and then we would set pen to red, and then that would be the active drawing color. We've got a backlight that we would set with the brightness level, and then a clear function. This clear function is part of the Pico Graphics library. We'll be creating another one to enhance that, and then the update. So now let's go back to the code, and here we will see we're setting the backlight to 1, whole number 1, and that is for full brightness. I like very bright displays. Some people like them more muted. Pick one that's your choice. I'm setting the font right now to bitmap number 8. We'll go into more detail on that later on. Now here I've got some boilerplate colors: red, green, blue, white, and black, pretty commonly used. And again, this one would be your red, this is green, and this is blue, that you would set the intensity for that color. Red is obviously pure red, green, full green, blue is full blue. And then white is all colors on, and then black is all colors off. And then our clear function, this is used to clear the display and erase it and plot it in the color that we want it to dictate or command for our background color. So I'm going to say display set pen to black. That gets the data from here where we created that pen. Then I'm going to call their clear option, the Pico Graphics clear function, and then the update command. Update actually performs the action. When we tell the display to do something, that something goes into a buffer. Then when we say update, it takes the data from that magical buffer, puts it on the screen so that we can see it. Now with most of the boilerplate code out of the way, we've got everything ready to actually start drawing on the display. And what we're going to be looking at are some of the graphic primitives that their library provides for us. And we'll go through these here real quickly, then we'll go into the code one by one with an example. We can plot a pixel at our X coordinate and Y coordinate. Pixel span, which will, from the starting point XY, it will draw a horizontal line going to the right for this length, number of pixels. We can draw a line from X1, Y1 to X2, Y2. That means a line at any angle. We can create a circle, and this would be a filled circle, starting at X and Y at the center, and it would have the radius. Here we've got a rectangle command that'll be filled, and it'll be starting at this XY coordinate, should be ideally the upper left-hand corner of the rectangle, going to the right by W with pixels, and going down at the H height number of pixels. So X, Y, upper left-hand corner, width, and height. We can draw a simple triangle at giving it 3 X and Y coordinates. And then finally we can draw a polygon of somewhat unlimited number of sides using a configuration such as this, where we're going to use square brackets and parentheses to define each of the coordinates. Moving along with our example program, going down, this will be the first area where we can actually start drawing some graphic primitives. All the stuff up above we've already covered, and consider it as boilerplate. So here we're going to call our function clear to make sure that we've got no residual data on the screen. And then we were going to select the white pen, and we're going to plot 3 pixels on the screen. And after we've commanded them to be plotted, we will do an update. You don't have to do an update after each command. After a series of commands, you can do an update as well. Remember, this is all being written to a buffer. This takes that buffer and puts it on the actual screen. Let's go ahead and run this, and it's going to be, I'll flat out admit, it's going to be very hard for you to see these little pixels. But over here, there's 1, 2, 3. Very, very tiny pixels. So now we'll go through, and then we will do that span command. Here we're going to continue our program. We're going to set the pen to green, and we will draw starting at 5, X5, Y5, and then for a distance of 50 pixels, we will span or create a horizontal line, and that's all this command can do, is draw a horizontal line, and then we'll do an update. So let's run that. And now we can see right above our little pixel here, here is our green line going across that we just commanded. Adding to our library, we'll use the line command. In this case, we're going to do a blue line starting at X0, Y of 135, lower left-hand corner, going to X plus 240, and Y of 0. So a diagonal line going from lower left to upper right. We'll run that. And here you can see our blue line. We'll add in the ability to make a rectangle. In this case, it'll start at coordinate 20 and 20, X, Y. It'll be 200 pixels Y, and it'll go down a distance of 95 pixels. Again, we create the command to do it and then have to update afterwards. We'll run that, and there is a mighty big red rectangle. And as mentioned, any of these devices or objects that we're drawing, if it's enclosed or can be enclosed, it will be a solid object. If you need just the outline, you have to draw it using either polygon or a series of lines. Now to draw a circle, we're going to set our pen to white. We will specify that circle to be at 120 on X, 67 on Y with a radius of 50, and that should be right at dead center on the screen. We're going to draw a triangle now right in the center of that circle using a black pen. And then these three coordinates were calculated using basic trigonometry to figure out where those are so that they're equally spaced. And then again, we always do our update. So we'll run that. There's our triangle right in the middle of the white circle. And lastly, we will do a polygon. We'll draw an irregular shape. This polygon will have 1, 2, 3, 4 different points on it, and it'll be along the left side of the red rectangle that we've got in there. And we'll go ahead and run that. And there is our polygon. That's how easy it is to work with all the basic graphic primitives that they provide in their library. Next up, we're going to take a look at working with the buttons. The RGB LED, we'll be using a Pimoroni demo program for that one. And then we're going to move on to text control. And they give us a lot of control and ability with their text functions. Now we'll take a look at utilizing the 4 buttons and the RGB LED. To do that, or to utilize them in our program, we need to load the related libraries, define the buttons and the LED, check the button state, that's how we determine if somebody presses it or not, and then set the LED color. These are the 2 libraries that are related to it. They're in the Pimoroni area, not the Pico Graphics area. So from Pimoroni, import button, and then import RGB LED. We're going to need to define the buttons and which pin number they're on. Now, by default, as we see here, if these were put physically back to back, there has to be predetermined buttons, or buttons to a certain pin number. And in this case, button A, 12, B, 13, X, 14, and Y, 15. Same is true for the LED. That's 3 colors, so it has 3 pins, 6, 7, and 8. Now, if we're wiring this up manually or external to a backer plane like this, you could probably utilize different pin numbers. I haven't done so, so I haven't tested it, so experiment on your own in that regard. To check the state of a button, we would use the command button _A, B, X, or Y, .read, and when called, it will return the state of the button as either true or false. True meaning the button is pressed, false meaning released. Then to set the color of the RGB LED, we would say LED.setRGB, and we would specify using 0 to 255 notation the intensity of each of the 3 colors. And then we could mix and match that as well to achieve the desired color that we want. Now let's take a look at this in actual code. This demo here was written by Pimoroni, or whoever they worked with to create it, but it's an excellent example of using the button as well as setting the LED to the color choice that you want. Here are the import statements. Here we're defining our LED as the RGB LED coming from that library, that class from that library, and setting the pins 6, 7, 8. little further down, we'll define each of the 4 buttons, A, B, X, Y, and which pin number they're associated with. Then down in here, we're going to go into a fairly large loop that is going to read a button, and then depending on which button you press, it will set the RGB LED to the color that is programmed for it. So in this case, if button A read, meaning if that read was true, that's the equivalent of saying if button underscore A dot read parentheses is equal to true, this is the shorthand notation of that. So if that button is pressed, clear it, clear the display, just set the pen to white, and then display the text, button A is pressed, update the display, and then set the RGB LED to white by setting all colors to full intensity, sleep for a second, and then clear. When it gets to the bottom here, after that clear, it will reset everything back to say press a button again using green text and update the display, as well as setting the RGB LED to green. So let's see how that runs. So over here it says press a button. I'll press A. A was pressed. It shows us that in white. B shows us in blue, X in purple, Y in yellow. That's how you work with the buttons. It's just a matter of checking the state by using that command, and then for setting the RGB LED, set the RGB color intensity that you want it to be on. If you want it all off, then you would set it to RGB 0, 0, 0, and that would turn all of them off. Now moving on to text, they have really done an exceptional job giving us a good variety of control over the fonts and the size of the characters, etc. There will be 2 different ways you can present text. It can either be a string of text or a single character. There's a difference between the two and why you might want to use that single character. And then you're going to have a choice of fonts, not only 2 different types, bitmap and vector, but several different fonts within each of those 2 categories. And then finally, size. You have a scale function that allows you to set the size of that font. Now we'll have to set the font with the set font command, and we would specify a font name. And you can choose from either bitmap fonts or vector fonts. Each one has its advantages, and I'll explain that in a little bit here. But under the bitmap font, the first thing to understand is if we're using a bitmap font, its reference point is the upper left-hand corner. So like in the case of the word bitmap here, it'd be the top left corner of the word or the letter B. You have 3 different choices there, bitmap 6, bitmap 8, and then bitmap 14 underscore outline. And that one's kind of a really cool one for you retro gamer guys. You'll recognize this font from a few years ago. Vector fonts, they're middle left aligned, so it'd still be the left-hand side, but instead of the upper left side, upper left corner rather, it'll be vertically the center of the characters. And here we've got sans, Gothic, cursive, serif, italic, and then serif. And we'll go through and I'll demonstrate what each one of these looks like in a few different sizes so that you get a little better understanding of how cool all this really is for such a little primitive display. The command to display text, a string of text, the first thing I want you to understand, it must be a string. Don't put numbers in there. If you need to use a number, convert it to a string first. X in the up here is the horizontal position, Y is the vertical position, and as mentioned, that's relative to whether it's a bitmap or a vector font. It'll be slightly different. Word wrap sets the position, the number of pixels before the text wraps around to the next line. And then scale specifies the size. This is a little tricky because it's a relative term between 1 and I'm saying about 10 because that's about as big as I can really fit something on the display. But most of what I've been working with, I think, is in that 2 or 3 range, depending on the font. The angle of rotation is the angle at which the text is displayed. It's not skewing it like you would see with an italic font. It's the angle at which it'll draw the text going up or downhill on an angle. That'll make more sense once we get into the example. But you can only specify that for a vector font. It will not work with a bitmap font. So that's one of the differences between why you would choose one over the other. And then spacing modifies the letter spacing. 0 is about normal or standard, and then you can increase spacing by putting a value in there. They give us a command to measure the text. You would give it the text, which must be a string, and then the scale that you plan to use for printing it in a range of approximately 1 to 10. And then spacing, same as described earlier. And that will return to you how wide that text string will be in pixels. And then that way you can do your own centering operations within your code, especially text strings that will vary in length. Very, very handy feature. Then we're going to be able to specify a single character. The character is an ASCII value, and you would get your ASCII value from a chart, unless you can memorize them all. And I'll show you a website that I use for this example here. But you're not specifying a letter here, you're specifying the ASCII value, and that's important to remember. X and Y is the location of it, and of course that still is dependent upon the font. And then we've got scale controls the size ranging from 1 to 10. Again, that's approximate. It depends on your font and how big you can actually get on the screen. Now let's take a look at this in code. Up at the top, most of this is all boilerplate that we've been using. I am using a button in this example program. This is going to be a function here where we're going to wait for a button. We're specifically working with button Y. And this just causes the program to stop until we press the button Y. That way I can step through each of the different examples of text and so forth that we're trying to demonstrate. Boilerplate, colors, clear, etc. Now at this point going down, we'll run the program and show you what's on the screen, and then we'll talk about what is here. Now before I do that, set pen, same rules as before. Set it before you want to draw an object. We do need to select our font before we write text, because it will use that font when it creates this text. So that's important, the order. And then here's our display text command. And you'll see that I've got a text string here, picoman, the position where I want it printed. And then I'm setting a scale factor to adjust it. Now you'll notice I don't have anything for word wrap or anything else in here, spacing, etc. You don't have to specify all the options. Just specify what you want to control. And then as always, anytime we want to write data to this display, first we write it to the buffer, and then we call the update to actually put it on screen. So we'll go ahead and run this now. Okay, here you can see that is scale 1. That's really, really tiny. Barely, these old eyes can't really read it. But scale 2, 3, and 4, very readable. Now we will go to the next one, which is, we're going to set the color to red, and we're going to use the Bitmap 8 font. So to move on, notice here we've got the command wait for Y, which is our button checking command up here. So it's just going to sit here and wait until I press the letter Y on the display. Now you'll notice that that one's very much the same as the PicoMan 6. Very little difference. Next up, we will show you the Bitmap 14 outline. And that one really looks cool. It's a little bit bigger. Obviously, they're calling it 14. I don't think that really means like we would traditionally think of in size for a font. But nonetheless, it's a very cool-looking font, especially for something where you want that nice retro look. I just love it. It's for some reason, it's really tickling me. Now we will go on to vector fonts. And so we'll hit Y, and there is a nice, clean, simple little vector font. And I've only printed one there. I think you're getting the idea of what scale is doing and so forth. So I'm showing it in scale 1 for all these vectors. Now we're looking at Gothic. In the car culture, I see this font used a lot on certain types of hot rod cars, typically a lot in the lowrider type cars. Very cool looking font. You got to be pretty aggressive to be using that font. It is a little bit on the difficult side to read. Next one will be cursive. Very cool, not a bad looking font, fairly legible. And now we're up to serif italic. And as you can see, it's got that forward slant. And again, that has nothing to do with the angle that's specified in the text command. The italics skew the font, and then the angle will allow it to print at a different angle. We'll see that in a minute here. And then one more, and that's just a straight-up serif font. Again, a very nice-looking font. So as you can see, they've done a very good job with fonts and the control of how that particular text is displayed with our scale command. Now we're going to move on to the effects of the Y position on the font selection. And this next one demonstrates that. Hopefully we can see it on screen. The top font is a vector font. And you'll notice that I put a reference line here. They're both at the same Y coordinate, the text and the line, but you'll see how the text is at the midpoint. Where on the next one, the Bitmap font, the Y coordinates are the same again for both the text and the red line, but notice the relative difference in position. So you got to keep track of that when you're switching between Bitmap or vector fonts. Now let's take a look at the effects of word wrap. Now in this first example up here, you'll see that the word wrap is set at 240, which is the full display width. So there is no word wrap. On the second one, I set the word wrap to 120, and you can see that right about the midpoint, it wrapped the text around to the next line automatically. Now that can be kind of a pain sometimes because it may or may not give you exactly what you want. So be prepared to do perhaps a little experimentation on that. Next up, we'll show you the effects of spacing. On the first one, we're using a spacing of 0. And on the second one, it's the same text, same size, of scale of 2. But what we're going for is the spacing is set to a value of 2. So it's presumably 2 extra pixels between each letter. And you can see it spreads it out a lot. I'm guessing 0 might be less than. I'm going to assume that 1 is probably the normal spacing. But that is the effect of spacing. Sometimes that'll give you the visual effect that you're looking for to tidy up the layout of your design. Now we're going to get into the angle. We're going to print this text both at the same scale, one at an angle of 5 degrees, one at an angle of -5. And again, this has to be a vector font. So let's see the effect of that. Now you can see one going down at -5 and +5. And then from there you can experiment around. It's pretty hard to predict how it'll all look until you actually command it, run it, and then go, okay, I got to adjust a little bit up or down. But it's a very cool capability in such a little display. Next up, we're going to measure a couple of lines of text. And here I'm using the Bitmap 8 font. Down here it's the Sans font. Same text. So what we're going to do is measure it with this command. We give it the text, the scale, and then the spacing, just as we would as if we were going to print it. But we can here, using just this command, we can measure the width, and then we could make adjustments to where we want it printed. Now here I'm also showing that my text statement is a string here, and in this case L is a number. It's a numeric value, the width in pixels. And so here I'm adding to our original text command the L, that length, converted to a string. So we add the two together, and then that's what we're displaying here. So you'll see the little one is Picoman 68, so 68 pixels wide, and then Picoman on the vector of a larger size is 166 pixels wide. So that gives you excellent tool for doing very cool layouts for nice tidy graphic designs. And then this last one we're going to do the basic character statement. So we'll call that up. And here I was printing each letter of the word Pico in a different color, red, white, blue, and then green. And I'm specifying the spacing by setting the X and Y position for each of the letters. And then, of course, the scale. But here you'll see that I'm using, instead of saying P, I have to use the ASCII code 80. Because the character function uses the ASCII codes. Now, that can be an advantage because you've got some other weird characters, weird, I don't know what else to call them, that aren't on, that can be typed out, so you can utilize other characters as well. Now, where would you get that ASCII value if you haven't been programming for a long time? There are a number of places on the internet where if you just type in ASCII chart, like I did in Google, and it'll bring up one of these charts. And for example, in this case, I'm looking for the capital letter P. I don't want to do this in hex. I want it in decimal, so that's 80. If I come back to my program, P is ASCII code number 80. So this one, it's a very handy tool for doing unusual things with text. But I think this kind of displays or showcases it quite nicely. And now for our last demonstration, I'll bring together a few different elements. We'll have graphic primitives to draw a scene. We will have some text and a little bit of animation to make it a little more interesting. I won't get into a lot of details. I'll let you sort through it in the code. But I'll just point out a few things here. Let's go down to how the scene will be laid out. In the main loop, we'll clear. We will draw some grass, a sky, a little stick figure here. And then we're going to call this function rolling, where we're going to move something from this X and Y coordinate to this X and Y coordinate. And if we go up to here, that's what's going on here. We'll be moving along from this X, this Y, X and Y coordinate, this X and Y coordinate in a loop. And during that loop, as something is moving at a couple different positions, we'll display some text. We'll display it and then erase it if needed. And then we're going to go through and display some more text at another position. And I just noticed here, I got to get an indent there. I probably bumped something with a fat finger. And then as this thing is animating, we're going to move a circle along, draw it in cyan to erase it, and then red to show it. So that's this loop here is erasing and drawing, just like I'm doing here with the text. So let's go ahead and we'll run this. We'll stop and we'll run. And I'll get this at an angle here so hopefully the moire patterns go away. And we'll rerun it again. Here's the little man saying stop, the ball's coming, it hits him, he says ouch, and he's gone. I guess little stick man had a really bad day. We used the red and blue flashing on the RGB LED to alert that the medical team is there to help our little stick man. But I think that gives you a simple little idea how you can have some fun with this display and use it in a wide variety of different applications. In truth, most of my programming stuff is more utilitarian. I don't do a whole lot of cool, fun graphic stuff because I frankly suck at graphic arts like that. But nonetheless, it's a little fun to mess with every once in a while. I do apologize. This video ran really long. I have no idea right now. I'm at 2 hours and some in editing or in recording. By the time I'm done going through editing, it'll hopefully shorten up a little bit for you. And this is why I really thought it'd be a two-parter. Now the second part probably won't follow right away. It'll be a few weeks out, but maybe even more. It could be months by the time I get it back in the schedule again. But if you got questions on this one, be sure to post it in the comments below. And again, I thank you very much for watching, and I look forward to seeing you in the next video.